Air traffic management is the most important system of events, which provides efficiency and safety of aircraft operations. A key component of the air traffic management system is a ground infrastructure consisting of numerous technical means of communications, surveillance, landing, and navigation. Modern technologies allow organizing air traffic at a new level, thereby creating an optimal air transport ecosystem. One of the key tasks of air traffic management is to monitor aircrafts. The task is to determine the location and parameters of aircraft in order to use this information to control air traffic. Primary radar is an independent method of aircraft surveillance. This method is based on the principle of reflection of radio waves from objects, which allows for the detection of any aircraft within range of radar. Secondary radars are active systems that require airborne transponders at the board of an aircraft. These tools allow you not only to determine the location of the aircraft, but also to seek additional flight information. Secondary radars have always been and remain the primary means of surveillance because of the greater range, higher accuracy positioning, and availability of flight information. Classical radar surveillance means are succeeded by the new technologies that take into account the latest trends in the development of navigation and communication systems. Automatic Dependent Surveillance Broadcast (ADS-B) is the one of such technologies. This technology is based on the principle when the aircraft independently determine the coordinates by signals of global navigation satellite systems and transfer them on the air. Ground ADS-B station is very compact and simplifies its placement and allows to use infrastructure of mobile operators. At the same time, the ADS-B technology has certain drawbacks. First of all, it is dependent on signals of satellite systems, as well as on the operation of the aircraft navigation equipment. Multi-position surveillance systems consisting of several land stations are deprived of such drawbacks. The principle of MSS operation consists in determination of coordinates of the aircraft based on the difference between the reception times of the signals at the different stations. MSS is full functional analog of secondary radar, possessing a number of essential advantages in comparison with. This is possibility to monitor aircraft at low altitudes, functioning in the conditions of challenging terrain, high reliability, as well as lower cost and operational costs. Important advantage of ADS-B and MSS technologies is the ability to monitor the aircraft at all flight levels, making them effective in air traffic of small aircraft, badly needed in the country. Strategically important task of air traffic in the country is friend for control of the aircraft, a so-called IFF. Now IFF tasks are solved by means of costly ground infrastructure based on the principles of radar. MSS based of IFF can become modern mean in solution of this problem. The introduction of such a system will expand the scope of the identification signals, significantly reduce the cost of terrestrial infrastructure, as well as not to make changes on board of the state aviation aircrafts. For the operation of the above technologies, except for the primary radar, there shall be a transponder on board the aircraft. Thus, to build economically and functionally efficient air traffic management system of the country, it is necessary to bind uniform requirements to the onboard equipment, which are in harmony in turn with requirements of other countries that will allow to simplify the international flights. One of the most important principles of air traffic management is the integration of all these tools into a single composite surveillance system, which will perform the processing and integration of data from all monitoring tools in a single interface. This composite system of systems will provide surveillance of aircraft in the air and on the airfield. The construction of such a system requires a comprehensive approach based on the principles of smooth transition to the new ADS-B and MSS technologies.